Welcome back, everyone. Back to the second Python tutorial seminar of our series. Hopefully everyone who is in attendance right now has already attended or watched the recording from our first session, which was on opening a .txt file. And if you had technical difficulties during that hour-long session, we hope that you were able to set up a meeting with us so we could work one-on-one to resolve that issue so that you're able to fully follow along and participate today. Before we begin, I need to review our code of conduct. By joining this Zoom call and participating in this tutorial seminar series, you are agreeing to adopt these values and engage in respectful communication only. If we see any inappropriate remarks in the chat, you will be removed from the call by one of the co-hosts. I also want to note that a few people commented last time that they couldn't see the commands at the bottom of my terminal because their Zoom toolbar was blocking that. And for that, I apologize. Unfortunately, I cannot actually move my terminal window around. It won't change how it's displayed to you. But we have three options. If you hover your mouse over the Zoom window, it makes the toolbar pop up. So if you have the ability to try to have your terminal and working space be not in the Zoom call, the toolbar should disappear and you should be able to see everything fine. You also have the option of changing your settings in Zoom so that you're viewing this call in side-by-side view. So on one side, you would see my shared screen, and on the other side, you would see me talking with my very animated hand gestures and whatnot. The screen might be a little bit smaller for you, but that is an option if your toolbar won't go away. And thirdly, I will do my best to clear my terminal in between commands. I don't want to make things disappear too quickly, but if I clear it after we have a long string of output, my new command will be at the top of my terminal and you should all be able to see it. And alternatively, all of the commands are available on our website or tutorial cheat sheet, which someone from the Xdev team will post in the chat the link to the content for this particular tutorial. So if you have that on one screen, you can kind of follow along and see all the commands written out there too. And I'm going to point you to two other Python learning resources that are just good to have in your back pocket. One is the Python documentation. That has everything that we're covering, pretty in depth, but maybe a little too in depth and hard to sort through, but it's all up there. And in our tutorial, we have links in various sections to specific parts of the Python documentation that we recommend you look at. And you also have the resource of Stack Overflow, which is a community resource, which means that people post questions in there and other users answer. And at this level, most of the questions that you will have or encounter have already been asked or answered up there. But unfortunately, you know, learning how to ask the right question or what question you need to ask to advance your project is also a bit of a skill that you develop. So that's why, you know, we're not solely giving you those resources. We're also hosting these tutorials to help you along that path. And one last reminder before we begin is that this seminar is only 1 hour long. So we cannot stop the lecture to give individualized attention to specific people in the call. You might be able to find help from fellow attendees or the Xdev team in the chat, but we hope you can follow along. And if you can't and have too many technical issues, please relax. Absorb as much as you can in the hour and just know that the recording is available, the website is up, and we are willing to set up one-on-one assistance after the lecture for everybody. Okay, we're gonna pick up where we left off 2 weeks ago to review. So give me 1 second to open up a terminal and leave this quick little PowerPoint here. Okay. Okay, can everyone see my terminal? Okay, good. So first thing I'm gonna do is move this a little bit. I'm going to move into the directory of our project from the last session. So for me, that was in my documents, and it's called Python tutorial. We're gonna take a look at what we did and just review what we have here. With an ls, that'll list everything we have. And you can see that we have our script, mysci.py, and the data folder, which inside of it just has our text file. We also have our corresponding Git repository and Conda environment that only has Python installed in it. And I'm gonna go ahead and activate that environment now. Conda, activate Python _ tutorial. Okay, I am now in the correct environment. And we are gonna take a look at our script file. So open up whichever text editor you preferred and used last time. Again, for me, that was Nano. So I typed Nano, and then the name of my script, mysci.py. Okay, so this is what we have in our file. We have 3 lines of code and 1 comment with the hash. We have read in our data as this variable data, and it's all in string format. So throughout the course of today, we're going to manipulate this data into a more usable format, which is the Python dictionary. We're going to learn how to write for loops and about Python data structures. So we're going to change the script, and we're going to split this long string up into a Python list. If you haven't opened your editor yet, again, please do so because we're about to start coding. Okay, the first thing we're going to do in this script is at the very beginning, we're going to initialize our data variable. So I am, again, making a comment just to specify what this part is. And I'm going to create my variable data equals open close square brackets. This is how you indicate a list in Python. And we're going to populate this list as we move through the file.
Julia, there's been a request to see if we can increase your font size.
Let me try. We
figured out how to do it in the practice, I remember.
I will. I am in it now.
It didn't seem to do anything.
Did that work? Okay, no. Let's try. We tried
Yeah,
this.
the command plus doesn't work, everybody, because command, that worked, good.
Did this work? I just made my terminal window smaller, and then maybe proportionally it's bigger in your call.
That'll do it. Okay, thank you very much.
Fortunately, everyone, the command plus makes the font bigger, but also makes my window bigger too. So everything is in the same ratio, and it doesn't really translate well for what we're trying to do here. So yeah. Hopefully you can see this.
Yeah, that's better. Thank you.
Of course. Okay, so we have initialized our data variable. Our file name is still the same path. We're not going to touch this. And our with omit statement, the beginning of this is the same, but we're going to go ahead and change what's within the block. So go ahead and delete the last line of your script. Again, if you want to have notes and know every version is still here, you are welcome to simply comment out the line if you're afraid of deleting it, but that could get messy and confusing, and we do have everything documented on the website for you already. I'm going to go ahead and delete the lines that we're not using anymore as we go through. Okay, and we're still indented by 4 spaces. 1, 2, 3, 4. And inside of this, we are going to write our first for loop. So I'm going to create a comment and I'm going to say read the first 3 lines or the header of our file. To make it a little easier for you guys, I'm going to just add a space here. You're probably already familiar with for loops from a previous coding language, so we don't have to go too much into detail, but we're going to mostly cover the syntax. And just in case everyone knows, a for loop is used to iterate over a sequence, which here is going to be range 3 since there are 3 lines in the header. So what this looks like is for underscore in range 3. This is how we're starting our for loop, and we'll go down 1 line, indent 4 spaces, and then to be within the for block, we have to indent another 4. 1, 2, 3, 4. Before I go into what we're putting here, let's talk a little bit more about the for statement. So this underscore is a placeholder variable. You could use any character you like. Maybe you're comfortable with an I or a J, as I was first taught when I learned my first language in MATLAB. But the underscore specifically is used in Python typically when you want to indicate that we're never going to call up this variable. We're not going to use the underscore. We're only having it be our iterator. And we're looping over range 3. So this would be like the same as saying for I in a list with elements 0, 1, and 2. This would be about the same, but range is slightly cleaner, so that's why we're showing you that way. And it's important to remember the colon at the end of the statement. Okay, 2, 3, sorry. 1, 2, 3, 4. Inside of this, just to kind of make sure everyone understands what's happening, we are going to go ahead and print the underscore. And what we actually are trying to accomplish in this for loop is to use our read line function that we covered last time. Remember, we covered read and read line. Read line only reads 1 line. So we're going to read 1 line 3 times just to skip through it. And we're going to stop here to make sure everything works as expected before we continue on. So I'm going to give you guys 1 more second before I exit this and run it. Okay. Saving my changes, and I run it with python mysci.py. And you can see that our output is 0, 1, 2, which are the 3 different values that our underscore takes within the loop. Okay, I'm going to clear the output. I'm going to try to get in the habit of doing that every time we have something. And now I'm going to open the script back up. We're going to remove this first print statement here. I showed you something once. We don't necessarily have to show it again. And we are going to add a second for loop that begins after we have read in the header. So we're going to comment this, read and parse the rest of the file. And what this for loop is going to look like is for each line in our data file, or each remaining line, so we're starting after the header and continuing until the end. And here it's also important to know that line is a string. If you remember, everything in our data file is a string. So each line itself is still a string. So the first thing we're going to do to our line is we're going to split it. So the way we do this is we're going to create a new variable. I'm going to call it datum, which is equal to our line dot split. which is a new function we're learning today. You can use a string.split method, which allows you to split up a string among a specified character. Perhaps you wanted to split a word up every time the letter A came up. But most commonly, it happens when we're reading in a huge data file, and this open close parentheses means that we're splitting along white space. You also could do something like this if you had a comma separated file, and another common one is \t if it's tab separated. But we're lucky, we get to just use the default, which is just open close parentheses. Okay. So each datum value is now a list of the string as it's been split up. And we're going to go into our data list, data.append. Append is another new function that we're about to learn. It takes whatever we put inside of this parentheses and tags it on as a new element at the end of our data list. So we're going to append datum. This means that every time we run through this for loop, the data object gets one element longer. And in the end, we have a list of lists of strings. Okay, we're going to add in a debug section at the end here, just to make sure everything's working how we expect it to. Comment debug for datum in data. We're going to go ahead and print datum. So this is going to go through our list of lists and print each list. Okay, I'm going to give you guys one more second before I close this and run it. Okay. And whoo, that's a lot of data. So, this is definitely a time where I'm going to go ahead and clear it. But first, you can see that each one of these square brackets, you can see me highlighting it, is a list. So this one here is the last datum. It's the last element in data. And every comma here separates a different value. And these apostrophes around it indicate, oh, I did not mean to do that, indicate that it's a string. Each element is still a string, even the numbers. We're just going to go ahead and clear everything now. And we are going to open up the script one more time. Okay, so we already covered a lot. You've initialized an empty list with square brackets. We've done for loops, placeholder variables, and we've learned range, split, and the function append. So there's already a lot going on here, and we are now going to practice a few different methods of list indexing, which is a very important skill for probably any coding needs you could have. And we're going to clear this, we're just going to be making changes to our debug section down here. It's the only thing we're going to be editing as we play around and learn a few different ways. And I'm going to go ahead and delete it in between each one. You can also just comment it out so that our output that we print does not get super long. Okay, so first we are going to learn how to pull out the first index from our list data. And we're printing it, so it's all going to be inside the print statement, but if you had to call it up for a different reason, you don't always have to print it. You could just set it as a different variable. But we're going to print data and then open close brackets 0. This is how you do indexing in Python, which is a language that is 0 indexed. So our first element is 0, our second element is 1, and so forth. If you have a list that can be indexed and you put these brackets after it with the number, it's going to return for you what that value now is. So this is how you print the first element. Now, any guesses on how to print the 10th element? I'm gonna just type out the beginning really slowly and kind of lag for a second while I give you guys a second to think about what goes inside of the brackets. If anyone said 9, good job, you got it. And one other trick in Python is that if you wanted to print the last element of your list, you do not have to know how long your list is. You can do negative indexing. So -1 means the last index and -2 means the second to last. I'm gonna go ahead and exit this and we can print it out by running the script and make sure that it works as we expected. Okay, so hopefully you can see this on your screen as well. We now have 3 different lists that have been printed. This one is our first list from data. This one's the 10th. And the third one is the last. Okay, let's open up the script one more time. I'm gonna clear it. Nano, mysci.py. And open the script back up. We're now going to practice what is called slice indexing. So this is, say, if I wanted to get the first 10 rows from the data, I could do that with, delete these 2, and instead of data 0 and doing that 10 times, I can put this colon here and put the last one. So it's exclusive of the last integer, and basically it goes start and stop. And if we run this, we've printed out the first 10 data lists from data. And it's a little hard to read, so moving forward, we're going to do it in a for loop just to kind of format how we look at it. So my for loop is going to look like for datum in data, and then here's where I'm going to do the indexing that we're selecting. Print datum. Now hopefully this is a little nicer to look at. Okay, there's still a lot of data that we've just printed out, but you can see that each list starts nicely at the beginning of a line in your terminal. So it's a little easier to think about. We're gonna also try, I'm gonna clear this one more time, open the script, and we have a few different methods. If we deleted this 0 and just did :10, what do people think will happen? Does anyone think this will still work? Let's find out. It still works, and it still prints the exact same output as last time. If you don't specify your starting index, Python assumes that you're starting at the beginning and that you're just printing the first 10 elements. Clear? Nano, mysci.py. We can also add a third number here, :2. These 3 numbers, you know, when there is a 0, it kind of maps to start, stop, and step. So 2 is our step size, meaning that we're only printing every other value from data. Execute this. Okay, so this is much the same as last time, but we've now printed out 5 lists instead of 10. Hopefully that makes sense to everybody. And now we're going to practice nested indexing. So I'm going to open our script. We're going to edit the debug section only. We're going to start fresh here. Okay, if I wanted to print the 5th element from row 9 of our script, that would look like this. Print data 8. So this first indexing, data 8, pulls up just that one list that it's pointing to, and then we open and close a new set of brackets to index from that new list. So 4. Sorry, excuse me for coughing. I guess that's part of why we're doing this remotely. So sometimes I've seen people try to do it this way because maybe it's the word nesting or something, but they try to do this. This Python does not know how to read this. We basically just have to set up the list, index it, and if that new thing can be indexed, we can index that. So to show that kind of, we can print 2 things. So first we're gonna get the same object, and then we can index it a 3rd time, possibly. I'm gonna go ahead and run this. Okay, does anyone understand what happened? So the first output is when we printed data index 8 and then index 4. And that points us to this value of 70.3, which still happens to be a string. And you can index lists or strings. We picked out the 0th index, so it just went to the first character of that value and gave us a 7. So you might want to be careful of that. Making sure that when you're indexing something, you're pointing to what you expected to. But I just think that might help people understand how this each step that you add to the indexing works. Clear? Nano, my side up high. Okay, we're also going to add a few different sections to the debug. It's just like a little quiz for yourself. Can you print out the first 5 indices from row 9? And can you also print out every other one from row 9? And I will kind of slowly build both of these out. And hopefully you guys have enough time to work on it on your own for a second. Okay, so this is what I have for my nested indexing. So you can see the first one we've already printed out, and it was something like 70.2. The second one, this is going to give us 5 different values. And then the third one, this is kind of similar to when we did every other step for 10, but you don't have to put in either the start or stop value. As default, they are the beginning and end, and we can just print every other one with : : 2. Okay, I'm going to go ahead and execute this now. Okay, and hopefully your answer looks the same. Okay, now we're going to show you something in Python that does not work, but that is a very common mistake or something that people often wish would work. And we're just going to show you. And again, if you're keeping everything just commented out, hopefully you have a code for yourself to indicate when something wasn't supposed to run, so you don't confuse your future self. So this time, we are going to try to get the 5th element from the 5th through 8th rows. Now this is not going to work. And if anyone can take a second to think about why. But maybe first thing is we can take a look at what our error message is when we do run it. Our index is out of range. So what this means is that the new list that we created, that is 5 to 8, does not have a 4th element. Oftentimes people are confused because our list is still a list of lists and every one of those has a 4th element, but our list itself is only 3 elements long. To take a closer look at why this is, we're going to go in here, and instead of printing the 4th element, I'm going to go ahead and just print the 0th element. This is the first one. And I'm going to print one more thing to show you guys that these are equal. We're going to print data 5. Close parentheses. Okay. Okay, so we've just printed the exact same thing each time. So hopefully that helps you see that data 5 to 8 gives us a list that's 3 long. And then our next index after that is indexing that new list. It is no longer indexing within that list, if that makes sense. I want to encourage all of you to practice on your own some more, because there's, you know, a lot of examples, kind of infinite possibilities. So please just check out some of the other learning resources on indexing in particular. A lot of these are posted in the various See More sections that you'll see as you go through the tutorial website. But because we are short on time and already more than halfway through, we're going to go in, we're going to clean up our script and do our Git Add and Commit. So I'm going to do clear nano mysci.py. We clean it up by deleting our debug section. Saving that. And then git add the name of our script, mysci.py. And then git commit -m, and then quotes our commit message, which I'm going to call parsing file. Now to see that this has happened again, if you remember, we can check git log, and this will show you that we have 3 different git commits so far, the 2 from yesterday and 1 from today. Okay, I'm going to clear this out, and we're going to begin the next section of today. I'm going to open up our script file so we can discuss that some more. Okay, so this is all great, but can anyone actually remember which column is associated with which variable? Was time our first column or our second? Where's temperature? It's kind of hard to remember. So instead of just storing things as lists, we like to store things as data dictionaries. They act much like lists in that they're changeable and they point to lists, but instead of an index that's an arbitrary number like 0, 1, 2, you can name those indices. So instead of indices, rather they are keys. We call them dictionary keys. So instead of the first element, we can say date, we can say time, and we can actually point to that using language that's a lot easier for us to remember. So we're going to go in and change our data to be a little bit more conveniently named. So here, instead of initializing data as a list, we're going to initialize it as a dictionary, which is curly brackets instead of square ones. And then inside our dictionary, we can store 3 different lists that we are going to initialize. The first one is called date, and that is going to map to an empty list. The second one is time, mapping to an empty list, and then temp out, which is the name of the temperature variable in our file. So each key is a string, and each one, the mapping is with a colon, and then they're separated by commas. If we wanted to pull out, say, just time, that would look like this. So it acts very similar to all the indexing methods that we just learned, but it's a string, so it's a word and hopefully a little bit easier to read and understand immediately what your code is doing. Okay, I'm gonna go ahead and delete this. That was just to show you how to do it. Okay, this is gonna look the same. Our with statement, our first for loop looks the same, but our second for loop looks a little different. So instead, I'm just gonna go ahead and change what we call the datum to, I'm gonna call it split line. It's a little bit easier for me to think about. And we are going to loop through each line and split it among the white space. And then we are going to go ahead and append the appropriate element from that line to the corresponding list within our dictionary. So data, which is our dictionary, and then we use our key to point to the list, and we can use our append method just like before. And what we're appending is from the line that's been split up, our first element, or index 0. Now it's going to look the same for time and temp out, but with index 1 and 2. Time dot append split line 1. Split line 2. So again, we are appending whatever's inside the parentheses to the end of a list, and we've specified that list by pulling it out of our dictionary using the appropriate key. We're going to add a debug section again just to make sure that everything's working as we expect. And I'm going to print data time. Okay, I'm going to go ahead and execute now. Okay, so you can see that we have printed out a bunch of time steps that are all strings. Let's go in again and clean up and add this to our Git repository. Clean up this time just meaning removing the debug section. Oh, sorry, I did not mean to run it. We aren't outputting anything, so that's why nothing happened. We're going to git add our script, git commit -m with our message, parsing select time series. And voila, everything is reflected in our Git repository, and we have 4 commits so far. So it's been easy right now to get time series information from each column. We have now worked around the issue that we can't just pull out the 4th index from XYZ indices in a single one line. We have to do it in a for loop for now. And we've now done it. So that's really great. But we still have to know the name of each column we're getting, and everything is still in a string. If we want to actually do math on this data, we need it to be in a different data type. So we're going to go into our script one more time to fix this. And it's really, we're just going to change one line here. Down when we append temperature out, what we're appending, being our split line index 2, we're actually going to insert another function right into the middle of this, which is float, which just turns that split line into a float. Float, the float data type refers to floating point real values, and it's the data type of any number with values after the decimal point. We could also make it an integer, which is int, which we would do if we wanted to. We could do int around float, and that takes the floating value and rounds it down to the lowest, to the whole number below it. You could not actually take integer of a string. It has to be in the float, so Python can understand that first. Okay, let me double check my parentheses right now. So we open, open, close, close, perfect. And we're going to do a debug section. We're going to print data temp out to see what that looks like. Exit, save, run. And we've printed out our long list, but this time maybe you'll notice there's not apostrophes around our numbers. They're no longer in quotes, they're no longer strings. They are real usable numbers that we can do math on. And just to kind of show you that we cannot do turn any value into any Python data type, it has to be something that object can become. If we tried to do float of a string of characters, like the word error, which is what I expect to get, and let's go see what we get. Okay. We cannot convert this string to a float. We were able to convert strings of numbers into a float, but Python will not let us do that. So we say, thank you, Python. Some languages, I'm pretty sure JavaScript does let you do that, and each letter just has a random number. It's not random, but it could be if you did it by accident. So we're gonna go in and delete this debug section. Again, we are going to have this represented in our Git repository. Git add, Git commit. This message, no space there. Converting temp out to floats. Git log -- one line, since we're getting a little long here. And you can see our most recent commit. Okay, so this seems really great so far. But looking at our script, you'll see that if we wanted to, say, add a third variable that we wanted to read in from the data file, we would have to change when we initialized our data dictionary. And again, within the for loop, we would have to add another line there. This means that for any one change in our script, we have to make 2 different changes. So it can be a little hard to stay consistent, especially as time goes by and you haven't revisited the script in a while. So it's best practice to try and lump things together so that you can see everything you have to change in one part of your script and it not being hidden in the middle. We're going to go ahead and we're going to refactor this code, which means we're going to move things around in a way to make it cleaner and easier to read for us. So we're actually going to start out by adding 2 new dictionaries to our file. Okay, so I'm going to go here, a few lines, our comment. Okay, let's see, where's my mouse? I'm going to first create a column dictionary. So column names and column indices to read. This dictionary I'm going to call columns. And it's a dictionary, so curly brackets. And we're going to have the same indices as before. Date, but instead of mapping to an empty list, it maps to a value. This value corresponds to the index of that column in our data file. Time mapped to 1. And temp out mapped to 2. We're going to add a second one for data types. So data types for each column. We're only going to do this if they're not a string, so we don't have to go ahead and do it all the time. So this one I'm going to call types equals, we only have one key here, which is temp out. It's the only value we're converting to anything right now, and what we're converting it to is a float. So I know before we used float as a function with the parentheses after it, and that can be slightly confusing right now because here I'm just writing float without that. The reason this is because this is a function pointer, which means that we're not actually calling or executing the function. We're just saying we can just pass around the name of the function and later on use it, which is very helpful and nice.
Julia, there's someone caught a typo up in the definition of the columns dictionary. There's an extra apostrophe after the 1.
Yes. Thank you, guys. Okay. So now our data dictionary here is going to look a little different. We are no longer going to already have it filled, but we're going to use a for loop to fill it up based on whatever we put in the columns dictionary. So for column in columns, 4 spaces, data column equals an empty list. So what this does is we loop through each of the keys in our dictionary. So the first time we loop through it, that key is date. And then we go in, we do data, we initialize a new list pointed to with that same key, and we do this for each one of these 3 keys. It's really great how you're able to just add a new key without having to go in and completely redefine your dictionary. So we can leave the first for loop within our with statement the same again, and we're going to scroll down, and I'm sorry that the top of my script is now off the screen. It's kind of the trade we're making for the font being big enough. And we're now going to change the second part of the script, because we no longer have to point to each index and each key. Specifically, we just have to call up the columns and the types dictionary that we created earlier. Okay, let me go in and do this. So we're still gonna have our split line variable. But then much like when we were initializing our data dictionary, we're going to loop through each column name. So for column, in columns, 1, 2, 3, 4, 1, 2, 3, 4. That's 12 spaces indented. We're going to create a variable I, being shorthand for index, which is equal to columns, pull out column. So again, the first time we loop through this, column is equal to date. And we go into our dictionary, we'll pull out date, and that maps to the index 0. Then we do time, and I becomes 1, and temp out I becomes 2. Now we could do the same thing for types, which we're gonna go ahead and call T. But because we only specified the type for 1 out of the 3 shared keys, we can do another dictionary function, types, which is our dictionary dot get column, comma, string. Now I'm just going to kind of show you down in this blank space what this does. So when we do a dictionary, so let's just say our dictionary is D, dictionary.get, and then in parentheses you have a key and a string. What this does is it first tries to pull out the key from our dictionary. And then if that fails because this key does not exist, we're gonna actually return the value string instead of whatever value that key would have returned. So that's kind of what our dictionary.get does. It just avoids key not found errors and allows us to not have to specify a bunch of things we're not using. So it's a nice little tool. Okay, so we're going to call it value equals T open close parentheses. So this is again where float is a function, but before it didn't have the parentheses, now it does. So now we're about to execute it. And what we are giving it as input is our split line at the index associated with the column name we are currently working on. And then the one last thing in this code is that we have to append it like we did before. So now we can just say column, which is going to be the string date, the string time, or the string temp out, and we append our value. So this is our new data dictionary. Just to test this, again, we're going to add our debug section. Okay, execute. Give you guys one more second. And run. Okay, so we have printed it out and it's floats and it's great and it's beautiful, and I'm going to clear it. And we're almost out of time, so which is good. We're coming to the end. The last thing we have to do here is clean up our code and commit it one last time so that we're all ready and set for our next session. Open up your script. Go down to the bottom. Delete your debugging. Exit it. Save it. Git add. Git commit. This time the message will be refactoring data parsing code. And just to check, we now have all of our commits represented in our Git repository. So thank you, everybody. This concludes the second lesson of this virtual tutorial. In this section, we have saved variables, date, time, and temp out into a data dictionary. You should now be familiar with data structures lists, their list indexing, nested lists, and the command list out append. You're also familiar with the data type dictionaries, their keys, the command dictionary.get, and you're familiar with ranges. We learned to write for loops about the float data type and using the command string.split. You refactored our code, we cleaned it up to make it easy for future manipulation. And that's a lot of different content to cover in an hour. So hopefully we moved slow enough that everyone could digest it. And again, if you had technical issues, please reach out so that we can get you up to speed and you can join us on November 11th. In 2 weeks' time, we're going to be using this data dictionary that we just created, and we're going to compute wind chill index by writing your first ever Python function and doing some basic math operators. So we're going to really get into the application of applying this data to a scientific workflow. Okay, thank you, everybody. And we can take questions at this time, or if there's any statement from anyone else on Xdev, you're welcome to unmute yourself now.
We've had a request to see the top of the script again, so that someone can see it. Just a reminder, you can also see the entire script on the website.
Here, should I, if I zoom out a little bit and make it the font slightly smaller, but you can see a little bit more of the script? Is that what we want right now?
Yeah, is this good or? Okay, doesn't seem as though there are any further questions. If anybody has additional questions or would like help, please reach out to us at the email that Julia mentioned, xdev@ucar.edu. We can set up a session and help you with any particular questions that you might have. And that's it. Otherwise, if you have questions, please go ahead and post them in the chat. Someone just said this part is still not clear. The _ in range 3. Okay, so what that is doing is range 3 is an iterator. It's equivalent to basically saying _ in the list 0, 1, 2. Okay, so a list that had 3 items in it. We're iterating over that list and putting the value each time for each iteration in that variable _, which is just best practice way of saying, I need to define this variable, but I don't care about it, and I'm never going to use it. And then every time it loops, it calls datafile.readline, which means it reads 3 lines. But it doesn't do anything with it. It just reads the lines and discards it. So what that does is it effectively reads the first 3 lines, the header of the file, which was not any data that we cared about, just the names of the columns, and sets it up so that the next read line, which happens in the next for loop, is going to be lined up with your first set of data.
I also saw a question about why you don't have to do an end for statement in a for loop as you do in, I know, MATLAB and some other languages. Well, in Python knows that you've ended your for loop because you already told it the for loop is only going to last for the length of X in Y. And once you've moved through all of those, it's done. And then also because Python is sensitive to white space, once we're no longer indenting, we are no longer within the for loop. There's no need for an extra line. It's already there in the syntax.
Yeah. There's another question. Let's see here if I get them in the right order here. You mentioned function pointers, and then could you please explain more about this? So everything, people will say this to you all the time about Python. Everything in Python is an object. And that means variables are objects. In some other languages, what you're used to is just being able to pass around by reference. So you actually, or pass around by value into functions. You can actually pass that variable in or its value into a function so that that function can then use it. In Python, since, quote, everything is an object, unquote, everything can be passed into a function. The name of functions themselves, the name of objects, the values of variables, everything can be passed in. So in that particular example that Julia has, where she's saying that this dictionary with the key temp out points to float, float is actually the name of a class. In other words, the name of a type of object in Python. And that thing, that class, can be used like a function. And so what she's doing is she's actually storing the name of the function so that she can then actually use the function later by referencing the types, temp out. I don't know if that actually makes sense to you. If that was a bad answer, I really apologize. I think any other attempts that I might have to answer that will just confuse you more. So I'll see if someone else has a better answer if that didn't work. Jeff DLB asks, are there other discardables like underscore? Technically speaking, the underscore is just one example of it. You could have, say, 2 underscores or 3 underscores if you had nested loops, for example. Any variable that starts with an underscore is also usually treated as a discardable. Like you could have underscore I, underscore J, something like that. But this is just a best practice. There's nothing in Python that actually says you have to use discardables. So if what you actually wanted to do was just call the loops, the nested loops I, J, and K, you could do that. There's nothing preventing you from doing it. It's become a common practice in the Python world that if you use an underscored variable, then it's sort of informing the reader, I actually don't really care about this, and I'm not going to use it later. So this is just a filler. And then you also ask, doesn't your use of range 3 read 4 lines? No, range 3 actually reads up to the 4th index. So it reads 0, 1, 2, right? and then 3 is the 4th index. And there's another question that says, do you have to set this to empty square brackets in the 4 columns and columns? Yes, you do, because what we're doing later down in the script is we're using the append method when we actually access data. And the append method only exists for lists. So if you hadn't initialized data column equals an empty list, then when you tried to access data column later on, or whatever the key happened to be, then it wouldn't know it was a list and it wouldn't have the append function, and you'd probably get an error. There's another question. How does types.get column string work with respect to columns other than temp out? Okay. So in other words, if column was equal to the string temp out, then it would just return types temp out. But if column was anything else, which is to say, if it was a key that wasn't in the types dictionary, then it would return str, which is that function that converts things to a string. Okay. So in this particular case, the function str doesn't actually do anything. It's basically a null function because it's already a string. These are good questions. There's a lot of content in here and there's a lot of subtlety. And there's no way we can cover all of it and actually end up getting to really useful stuff later, like NumPy, which we'd like to do in a reasonable amount of time, especially if these sessions are only every 2 weeks. So I really recommend that if you want to know a little bit more depth, look up the Python documentation on these things that we've just introduced you to and go a little further. There's a lot to all of these things. There's a lot to lists. There's a lot to dictionaries that we aren't even covering yet. Okay, and then Joe asks, why do you refer to the data dictionary elements using bracket when it's not a list? Okay, that is a little bit confusing. When you have a list called, say, X, to get any item in that list, you use X square brackets and then the index. Square brackets is Python's way of getting an item from something. In other words, it doesn't matter what it is. It just also happens to be how to initialize a list. So that's a little bit confusing. You use square brackets to get the item of anything, whether it's a list or a set, which we haven't covered, or a dictionary. You use square brackets to get the item inside that container. But when it's on, if you think of it this way, if it's on the right-hand side of the equation, you're setting something equal to it, then square brackets is shorthand notation for initializing a list. And then curly brackets is shorthand notation for initializing a dictionary. And then Evan Meeker says, so T is acting like string function in the next line. Exactly, exactly. There's a lot to digest. I'm happy to continue to answer questions if you've got them. Is there a vector or array data type that will only take elements of a single type like int? There is in NumPy, but there isn't in just raw Python. In Python, Python has generic container types like lists and dictionaries and sets, as I mentioned, which we haven't covered. And The general rule of these generic data types is that they can contain anything. And they don't have to be uniform types. So like you can have a list that contains a string in the first element and a list in the second element and a dictionary in the third element if you'd like. There's nothing that prevents you from mixing types in Python containers. But what you're getting at, this ability to basically have an array or a vector of uniform types, gives you efficiency. And that's something that NumPy is going to give us later on. So we'll cover NumPy later, but we're starting at a place to give you, hopefully, a foundation in just Python by itself, so that when you then introduce NumPy, you don't get completely lost by the Python. Okay, and there's another question. List equals array ... dictionary equals hash. Yeah, in a sense. Yeah, a dictionary is a hash map. And in fact, I think it's implemented that way in C under the hood. Not a simple hash map, but essentially a hash map, yeah. So the keys in a dictionary have to be hashable. The keys actually could be integers if you wanted. They don't have to be strings, they just have to be a hashable object. And lists are akin to arrays. They're actually closer to linked lists, which should be, if you're familiar with linked lists, should be a sounding alarm bells that that's not a hugely efficient data structure to use. So yes, it will not be as efficient as an array, but it works like an array. Okay, and Jeff DLB says, looks like _var is just a convention to show we don't care forever, but the value last assigned still persists in outside the loop. Exactly, that is correct, yeah. It's just a convention. And Evan asks, why do you not need something like the append method when adding each column to a data dictionary? Okay. You need an append method with lists because lists are ordered. They will always retain and care about the order of the items that you added. So you need append so that when you add something, you know where you're adding it. You're adding it to the end. With a dictionary, the items technically are unordered. Now, as of, I can't remember which version of Python 3, dictionaries will retain the order that you added to them. But that's really just a convenience thing. Dictionaries don't actually technically care about the order that the keys were added. And so you can just add them with the square brackets notation that Julia used. Hope that answered the question. Let's see here. And then the next question from Tammy's iPad is, how do you print a single variable like temp out from the data dictionary? Okay, so what Julia created was a dictionary with keys that mapped to lists. So if you wanted to get, for example, the 10th item from temp out, the temp out variable, this is what you'd type, and I'll actually type it into the chat here. You'd say data temp out. Yeah, that's right, Evan. If it was the 10th item, it would actually need to use the 9 index. That's correct, yeah. So I just repeated what Evan said, but yeah, that's exactly right. No worries, Evan. You beat me. You're a faster typer than I am. I hope I didn't miss anybody's questions. If I did, please repeat them. There's another question. If your data has headers, you would use a different process. Is that correct? I guess the question would be to clarify, instead of creating a dictionary. Do you mean if your data had like column names at the top? Is that what you're getting at? Okay. Well, this data actually does have column names. They are spread over 3 lines. So actually getting the names of the columns is a little bit trickier because you'd have to parse 3 different string lines, split them, and reconcatenate them in the right ways and so forth. So we just didn't include that in here. But you could actually read the headers as just with a single like data read line, split on that, and use that to initialize your data dictionary. Use the actual string values to initialize your data dictionary. You could do that. Although in that particular case, you wouldn't exactly know what the names of the columns were. They would be an internal variable, and so it would be a little bit trickier. You'd have to write a different set of code, that's for sure. Yeah, exactly what Evan said. Any other questions?
Hey, thank you, everybody.
Yeah, thank you very much, everyone. Appreciate the thanks and the comments in there. I'm sorry if I couldn't get to everybody's questions. There was a moment in there where the chat was kind of exploding and I couldn't keep up with everything. So if I missed your questions, I really apologize. Please send them to xdev@uncar.edu and we'll answer them if we didn't already. Thank you all. See you in 2 weeks.